Everyone who's here, where's everyone? Pop quiz for 50 points. Sign your name. Oh yeah, it's like. Okay.
What is still?
We'll talk about AWS today, but for that, I want to talk about grading status. So we released the scores for PS5. There are a number of people who are missing scores, or we sent out some emails, we're collecting some data. The TLDR here is, if you're missing a grade for PS5 or any of the PSs that you think you should have been graded, please come speak to me. We want to find your work, we want to grade it, we want to give you credit for it. And if you missed an assignment or completely blew an assignment and you're really concerned about how this will affect your grade, come speak to me, because at the end of the semester I have broad leeway, being the professor, to make decisions on grades, and if you come work with me, I can help anyone succeed or at least pass the class, okay? So if you have any concerns, please come see me. And do it soon rather than finals week. Final project. 31 teams were declared. There were 8 two-person teams, 23-person teams, and 3 four-person teams. So if you're in the 2-person team, I still expect a significant, exciting project. And if you're in that 4-person team, I expect that extra person to really wow us with all the extra contributions. There are 12 teams that are planning to do some sort of game. 7 are going to expand the Learning Outcome Tracker. 6 are doing some sort of web info, and that basically is the gamut of anything that has a database in the back end that shows information on the front end. 4 of those 4 more web info teams are going to scrape data or get data from the web to display in a different manner, which is sort of nice. And then there are 2 web stores, so new eBay startups that are coming out, so that'll be exciting to see how those work. So that's what's going on. A couple of words of advice. When you are pitching an idea, whether for school or a startup or your boss, you want to appear as professional as possible. You want to spend a little time making your documents look good and your writing sound good. And I'm sure you've heard that from your writing instructors before. I have some examples here of some nice things people did, so let's go take a look. So here's an example, a nice header, it's in a different color, big fonts, easy to read. And then this team's doing a battleship game, and they say, hey, here's a reference. So anyone who's my age should have seen Battleship, and so they give me a reference and makes it easy for me. Rather than just say Battleship, they took 5 seconds, Googled, stole an image from the internet, and put it in the document. This is very useful. It gives us a pictorial idea of what is going on. This team used a nice template. In fact, I think 2 teams used this exact same template, which, by the way, is a word, like, if you are like 50 teams are all competing for the same spot, you want yours to be professional, but also have your own unique stuff. So don't use the very first template that Word or PowerPoint or whatever suggests to you. But again, this is a nice template, easy to read font. It's got just a tiny bit of bling that makes it look professional. Each section has a little thing under it. Everything's bulleted or highlighted. Sections have different boldness, sizes. And then there's this really sort of nice user feature table. Like, here are the features. Here's who's going to be working on it. It's a very easy way for someone to understand what people are preparing. So tables like this, nice, good-looking, easy-to-understand tables are a plus. Here's the same template. That was another good design. Again, this one, though, I wanted to point out is they used a whiteboard and they just did a mock-up. Okay, I think it's going to look like this. We're going to put some things here. And they drew it out and they took a picture of their phone and say that, hey, this is a great way to go about recording your ideas without having to spend very much time, because most of you can sketch on a whiteboard pretty efficiently. So I thought that was a good thing to do. This team, instead of using whiteboard, actually made some mock-ups. So they said our web page will look something like this. It probably took more than, like, the whiteboard is faster. This probably took a few extra minutes to do, but still provided some nice overviews. Oh, Okay, on the web page, obviously it'll build some tables, some buttons. This looks good. It makes it really easy to visualize what's going on. And again, it didn't take that much time to generate this, but the reader now is going, oh, all right, great. And then finally, here's a team that came up with a really neat logo at the top. So I don't know if they stole that. I'm sure they did. But it's cool. It looks good. They used IIS and then renamed it, which is, in my opinion, pretty cool. But don't use an acronym everyone else already has outside of school. Very nice. You know, the sections are in a different color. They're numbered. There are subtitles. It just, it's all laid out well. They're bulleted lists, numbered lists. They have some figures to support their document. So I thought this was a very professional look at how you go about describing your project. So again, now it turns out that like most CEOs, I did not read every word of every one of your project descriptions. Shocking. Yeah, I know. CEO is going to look for your abstract. Does it sound interesting? They'll look, do you look professional? And then if both of those are true, then the CEO is going to spend more time reading your document. So it's important not only how you write, but how you present your writing, how you capture the attention of the reader, that sort of stuff. So I brought your work up here, or if you saw things that are similar to work you did on your pages, good work on your design document. Now, by the way, doesn't mean that any of those actual projects will be great or stellar or anything like that, but it does, give you a sort of edge going forward. Okay, any questions on those? Comments? So how many of you know, before I went on my little rant, that presentation is important? I mean, you already knew that. How many of you knew that and didn't spend a lot of time on your presentation? Yeah, so there's that matter of time. Okay, towards the final project. Our course is web software architecture. It's not team software practice, it's web software architecture. It's also not game development or something. So when you're building your final projects, I do expect, aspects of web software, front end, back end, to be there. So if you're one of the, for example, game teams, you still have to have something interesting on the back end to show that functionality. Also, it's like you could spend the entire time drawing really beautiful widgets for your game, or for that matter, drawing really beautiful images for your website. But you're not going to get a lot of credit for that because that's not the purpose of the course. That's something you should plan to do over winter break when you have some extra time. Some general advice. So a number of the game teams propose a game, from my perspective, it looks like we'll have a blob down here, another blob moving, and some of those blobs will go away. And I was thinking, well, my Connect 4 game, I could, in like 20 lines of code, change my Connect 4 game to have a blob at the bottom and other blobs coming out. So you do need to make sure that there is sufficient content to your game. A number of people said, well, we're just going to keep high scores based on, someone will type in their 3 initials. For all of our projects, you should have a persistent database and persistent users. Now, you can make an argument whether this is really needed for a fun little game app website, and I would probably agree with you. But for our purposes, I want to make sure that you are able to re-implement a user system like the identity system. So, be aware. I suggest that you have at least 4 pages for any application. 4 pages that have interesting functionality. For the game people, like one team had already said this idea, and I talked to some other teams about it, but for example, you could have a web page that's completely unrelated to your game where a user can go in with currency and they can buy upgrades. So is anyone not familiar with the idea of pay to win? So pay to win is where people who pay money have an advantage over people who don't pay money, even though the game is supposed to be free for everyone to play. So implementing a pay-to-win, let's get rid of the moral philosophy. I really like the idea, but you could have a website where you can pay to upgrade, and then you go in the game, and based on your login and your payments, you get more zappers or whatever it is you need. So that would be an easy thing that all the game teams could add on. Yeah?
So, what if we have like a non-trivial game that's like pretty complicated and has power-ups and other stuff, but outside of that, we don't have much like fancy stuff in like web application. Is that all right, or would you rather?
I would like you to take some of the functionality time that you will spend on features of the game and put it in the back end, yes. So like you say, you have a game with power-ups and stuff. Great. Some of the power-ups, you just like a traditional game, you earn them in the game. Take some of those power-ups and make them where you have to buy them on a separate website, and then they show up automatically in the game. That's a way to show both aspects. Right. And again, will your final game have this mechanism in it? No, but the purpose of the class is to show off not only how cool your game is, but technical capabilities. Any other questions? Again, remember, everyone's expected to do good work, provide strong functionality. You have a month of time. Please get started. You should already be started this week working on stuff. Don't expect to finish a really top project in the last week of class, even though some of you are already thinking, I'm going to start this next week sometime. And then next week you're thinking, well, I've got something else to do. I'll start it the week after, right? So, for example, as an individual, if all you're responsible is making sure the database tables are good, that's probably not enough for this, what we're expecting from each of you. All right. Finally, if you have any concerns about your project, if you want to debate how to do it or what back-end functionality there should be, come speak with me. You speak with me after class. You speak with me during office hours. I would really like to talk to you about your projects and help you and I come to an agreement on what's really good for those projects. Are there any questions? Yeah.
Is it safe to assume that if we don't hear back about like if our scope is too big or too little, then we're fine with where we're at?
So I reviewed all of them. There's only one team who I thought was projecting more work than I think is reasonable. Almost all the other teams were, either light or okay. So you should review your stuff. If you have any fears or qualms that you might be like, come speak with me. And I will actually send email to that one team telling them, hey, this project sounds really great, but are you going to spend every weekend working on it for the next 4 weeks? The other thing is, so there are these broad categories. There's this 12, the 7, and the 12 teams. Find another team that's in your category. If you're making a game, find another team that's making a game. Ask them what's your functionality, how much you're doing. Find 2 other teams. Talk to them about what they think can be achieved. We can help balance ourselves by seeing what everybody in the class. If you're the learning outcome tracker, talk to some of the other teams that are doing that. What extra functionality are you adding? What could we add? That sort of thing. And if you're doing one of the web info or one of the scrapers or something, talk to one of those teams about what they're doing. That can help you gauge if you're on the right track. How many of you know at least one person in another team? How many people don't know a single person in another team? Oh, turn to your left, turn to your right, say, hi, I'm Jim.
Yeah.
Me, somebody else. Say that me?
Me too. Yeah.
Say hello.
I know you show my teammates, and that's basically it.
Yeah.
Feels bad.
I know a bunch of
See, this is true. The very fact is, like, we haven't had a lot of, like, group, work, so I guess that makes sense. We haven't worked, so,
What do you guys do?
Oh, so we were the first one, but that's we're doing the game. Yeah, we have, he didn't go throughout, like, the whole documentation, but we have kind of like a mock-up as well.
And we were
The fitness. Yeah.
All right.
I recognize that one.
So before class on Monday, I would like to challenge each of you to step outside of your comfort area and talk to someone else in the class before we begin on Monday. So get to know some more people. But that being said, I want to move on and talk about AWS. So if you could go to the quicker question. I just want to figure out how many of you have actually received an email from AWS. You should have at this point. So go ahead and put that into the clickers. While you're doing it, was there a question? I know some emails have gone out because 11 students have logged in already. And we're going to talk about that all today. Okay, so while you're entering that information, I'll just say a few things. One is I've created an AWS Educate Classroom for our course. In theory, I can add all sorts of interesting stuff to it, and quizzes and assignments. I don't think I'm going to do that, but maybe. But the big word is that by being a member of this class, you get $50 of compute time. Now, what is $50 worth of compute time? So last week, a couple of you said you've already done some cloud stuff. So someone who's done cloud stuff, what is $50 of compute time? What is $50 of compute time?
Many months, as long as your traffic isn't like overwhelming, you don't have a ton of data stored in your database.
Yeah. So what we're going to find out is it depends on what kind of compute engine you're getting and what kind of traffic you're getting, how much it's going to cost. We are going to start with a very low-tier system, which should be enough for our needs. If worse comes to worse, we will actually boost that up to a real system for the last week of class. But I've spent, 20, 30, 40 hours on AWS over the last couple of weeks, and I've spent $5. So I don't think there will be any problem with that $50 lasting. One thing to note, if you all of a sudden requisition a supercomputer or 20 supercomputers, that money will go away. And then at the end, when I say put your system on the cloud, you'll have to come to me and say, well, Jim, I wasted all my money. I can't put it on the cloud. Now, the nice thing is you're on a team, and so probably we'll only have one team member have to put it on the cloud. But everyone should, at some point, put one of their systems on the cloud just to get experience doing it. Okay, so let's take a quick look at what we got here. Okay, so 50% of got our email. 20% have signed up and 10% have signed up to visit the classroom. Great. 20% are rock and feel no pain. If you have not received an email by Friday, send me, my Jermaine at CS email, a direct email telling me that you have not received it. Before you do that, please check your spam in case all these AWS ads are going in your spam folder. But I want to make sure that everyone gets access. Okay. So one of the interesting things here, I think I said this briefly before, but AWS outsourced their educate mission to this company called Vocarum. And so Vocarum is in charge of the classrooms and the compute. And as far as I can tell, they were really smart to get on board first because they're absolutely awful. I mean, just terrible. I mean, I'm not saying the company is terrible, but what they've done with AWS is like they have a couple menu boxes that don't seem to do anything, and the whole page looks bad, and yet they are the partner with AWS, so somehow being first is a really powerful thing, which if you're an entrepreneur, you should know that. Okay, for example, some of the functionality, and it could be that now that we're a classroom, things are better. I'll be testing some things out. But I went to the billing page to see how much it was costing me to run my compute. And it said, you don't have access to this. It's like, well, that's not useful. How am I going to learn how much it costs if I don't have access to the billing panel? All right, well, let's get started. So when you are running this, you will go to the AW Educate site, and you will sign up for a classroom, or if you follow the email, you'll sign up for a student account. As I understand it, there are two types of accounts. One is a free account where you just put in your name and stuff. The other is one where you put a credit card in. And the credit card one gives you more access and stuff, but you shouldn't have to do that for this course. You should be able to do the completely free account. You should then get an email, and it says like, congratulations, click here to sign in, and you click on that button and go to a random web page that doesn't say anything about signing in, and now you have to look around for where to sign in, where to register. And just again, the way they put this together has not been inspiring. But eventually, you will find the AWS Educate login, and it'll pop up like this, and you'll put your email, u12345@utah.edu, and your password, once you've created your password, and you'll be able to log in. And you'll get to a page that looks like this. Choose your role: student, educator, veteran, institution, or company. In this case, you should be a student as you sign up. Here's where you put in your birth date and your country and last name. So you'll fill out all that information. You'll click that you're not a robot. And eventually you get your account. And finally, when you sign in, you'll get to a page that looks like this. So AWS Educate. And begin your journey today. There are a lot of linked videos and tutorials and write-ups. Do your due diligence. Do some reading. Actually click around and explore these things. I will show you the direct path to what I need you to do, but as time permits, spend some of your time looking around doing stuff. For example, there's this video on the starter account that you can play and see what they say about your starter account. On this page, they have a My Classrooms button. So if you click on My Classrooms, you will come to another page that looks like this, that has web software architecture, and oh look, I'm the educator, and the course ends in December, and you should each have $50, and you will accept the invitation. So once you accept the invitation, you'll become part of the classroom. As soon as you click Accept Invitation, it will actually pop up a giant Terms of Service. And just like the rest of us, you will scroll through this whole thing, not read it at all, and click I accept, thank you Amazon for your generosity. Should give extra credit for someone who actually reads through the terms and finds all the bad stuff we've agreed to. But anyway, once you do that, you'll click Accept Term. After you accept, you'll click Go to the Classroom. And then you'll finally, after all of this, you'll get to what looks like a readable page. So welcome to your AWS Educate account. It will say the most important stuff is up here in the upper right-hand corner. And that $50 is the thing that you want to pay attention to, because the longer you play with it, the more that will go down. I'll say this once and then I'll say it multiple times. If you don't need your computer in the cloud running, do not leave your computer in the cloud running. So if you're not developing on your computer, shut it down. If you don't need a computer, shut it down. If you're not going to use it for a week, delete it. Because if it's running the cloud, it's using money. Now, that being said, it's not a lot of money. The low-end instances will not cost very much. You could leave them up and running. But at the end of the semester, like the final week or so, I'll ask that you create a medium-level instance and you leave it running so that we can grade on it and we can visit it. But when we're not grading and you're not using it, shut down your instances. Okay, once you're at this location, you click on the AWS console, and the console will take you to this really cluttered web page that has all sorts of stuff on it. They're trying to sell stuff. They're trying to give advertisements. They're trying to get you to do things. But the most important thing is the All Services. So if you click on All Services, it will come up with all the different things that AWS offers. It turns out AWS offers hundreds, thousands of different things you can do. We're not interested in that right now. All we are interested in is the EC2 link right here. Hopefully I have an arrow. Yes, EC2 link. Does anyone know what EC2 stands for? Does anyone guess what one of those C stands for? All right, what are C words in computer science? Constant. Nope. Cloud. Yes, cloud is one of those words. What's another word that starts with C? Computer. Compute. So cloud compute. and the E is elastic, so elastic cloud compute. What that means in a nutshell is you buy and use only the computer power that you need, and if your company blows up in a good way, becomes really good, it will expand with you. You get more computers very easily. In the old days, and even today, some companies will buy their own web machines, so they'll buy their own data center. How many people work how many work here for a computer company? How many of your companies have their own compute? So you have your own compute power. Yeah. How many of you work for a company that leases space from one of the big providers? Yeah. So right now it's a toss-up. I think the trend is to move away from local data centers for a company and just use the cloud. Is probably what most people are going to. Okay, you click on the EC2, and we come up to our very interesting web page, which is our dashboard. And on our dashboard, we will see a list of all the things that we care about. The number one is the number of running instances. So if you have something running in the cloud, it will show up here. Then there are other things like volumes, which are your disk space, security groups. Those are minor things. They'll probably stay around for a while. I do think if any of these things are non-zero, you're paying for them. So like the security group is stored on disk somewhere, which probably means you spend a penny every day to hold that disk space. All right, so once we're here, we can spin up a VM, a virtual machine. And so that's what I want to talk about. Okay, so I'm going to go through a lot of web pages and a lot of things on there. Please ask questions as we go, because otherwise it's me just blah, 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 and you going blah. Right? So let's make this a conversation as we talk about it. So I already told you there's a regular account, requires a credit card, and a starter account, which is free and capped, so it doesn't require a credit card. Full disclosure, last time I ran web software, we used Azure, which is Microsoft's version. And Microsoft very nicely said, here are virtual machines for everyone in the class. And we didn't have to worry really about payments and stuff. And they were Linux-based machines, so it was a different experience. So I'm a first-timer using AWS, so we will be experiencing this together, right? Neat story on that Microsoft thing. Microsoft donated the compute to the School of Computing, and at that time they didn't have an education thing, so they wrote a document saying the School of Computing accepts $200,000 worth of compute time. So Microsoft basically said that they were donating $200,000 to the School of Computing, or maybe it was $50,000, but it's some enormous amount of money completely out of whack with what the real world compute costs were, and yet Microsoft's really smart because they can write that off on their taxes as a donation to the university. Okay, so we click on AWS page, and we come up to here where we have, once you go to AWS Educate, you're going to have two buttons. You're going to have the main button, which is Join, which is really strange to me. Why would the main button be Join? Because how many times do you join? Once. So why isn't the main button Sign In? Who knows? And then up there they have Sign In, which you're like, oh, I'll just click that button up there. Well, it turns out that's the wrong button. You have to click this tiny little thing down here to make it work. So you have to click Sign In to AWS Educate. Once we get here, then we have to choose AWS account. Like I said, maybe you should be reading and looking around and experimenting with stuff. Okay. But here we go. You have $50 in credits, and we click on the AWS account starter, and then you have this AWS Educate Starter account button that you click on. And by the way, we're going to do this live in just a second. I'm just walking through the steps. You click on that, and you come to this point, which is similar to what I showed you just a second before. And then you click the AWS console, which takes you to the similar page. One thing to notice now is, let's back up one page. On this page, your login will be UID at utah.edu, just like mine's Germain. when you click to go to the Educate console, all of a sudden it will change to Vocarum start soft / user 3 blah blah equals Germain. So they change your user as you go into their education system. It shouldn't have any effect, but you should be aware of that. Another very interesting thing is these computers are actually, even though I said spin up a virtual machine, they're running on physical data centers somewhere in the United States. And there are data centers all over the country. In our case, the generic data centers are in North Virginia. So it should say North Virginia up there. You can change that. For a while I was going to Oregon and putting my data servers in Oregon, which seemed closer. I don't know if it matters with the internet anymore, but it seemed better. The thing is, every time you log in, you go to North Virginia by default. And so I would come up and it would say 0 instances are running, even though in Oregon, a lot of instances were running. So be aware of where you actually place your machines and probably just use the default. And then we're going to use EC2. We come here, we check the number of running instances, there's 0, and now I want to create an instance. Okay. So I don't know why I cropped it out right down here as launch instance. So again, we'll see that in a second. But once you launch an instance, you'll come up and you've got many choices. So there's a huge list of types of operating systems and computers you want to use. And so there are two main groups, Linux and Windows, for our purposes. You can either have a Windows server or a Linux server. We are using Windows because it works really well with Visual Studio and C#. Linux turns out to be cheaper. Anyone want to guess why Linux is cheaper to run? Yeah, what?
Licensing or something?
Yeah, every time you spin up a Microsoft server, you're paying for a license to Microsoft Windows. There is no paying for a license to Linux because Linux is open source and free. So you can get a lot more compute power more cheaply if you do your work in Linux. All right. But we are going to choose, so like we could do an Ubuntu server. We're not going to do this. We're going to just choose a Microsoft Windows Server 2019 base, and that's going to give us a Microsoft Windows box. We then will select that and move on, and then we have to choose a machine to run it on. And now they have a huge selection. So we have T2 Nano, T2 Micro, T2 Small, T2 Medium, and there's like 50 different variations of types of machines. And every one of those has a different cost associated with it. And if you're running a business, you actually have to get a spreadsheet out and look at what are all these costs and how much you're going to use and what's the actual cost going to be. But for our purposes, these T2 micros are probably good enough. And it says free tier eligible, which means it costs almost nothing to use. And so we are probably going to use T2 micro. Later in the semester, we might spin up a T2 medium or something, because a micro has 1 CPU and 1 gig of memory. Now for me, 1 gig of memory is an amazing amount of space, because I grew up with 1 megabyte of memory was $10,000. For those of you who don't know, 1 gigabyte of memory is not really nowadays a lot of space. Windows 10 requests, like who's bought a computer last year? How much memory did you get? 32 gigs. 32 gigs, yeah. So how much does Windows want to run nicely?
8.
What's that?
8.
I think 8 is high, but maybe that's just advertising. Maybe it really does need 8. But yeah, Windows probably wants at least 2 to 4 gigs, and so we're going to throw Windows on a 1 gig machine, and you'll see that it runs a little slower than you might be happy with. There's a question?
Yeah. So like T2 micro, small, medium, are those like industry terms, or is that proprietary like labels just used for these like setups that just happen to be?
These are Amazon labels. So T stands for something. I forget what it is. Okay, so we're going to select this T2, and we'll look at the network performance. So low to moderate. All right, does that matter to us? So we're doing the learning outcome tracker, let's just say as an example, and a professor is putting information in the system. How many web page loads is a professor going to take in order to load their information?
One?
What do you think? Half a dozen, 6, 10. Let's be generous. 20, 50. Okay, so we have to do 50 requests to a server over a couple hours as the professor is putting stuff in. Is that a high load on a server? No, absolutely not. Right. So our usage is really low. On the other hand, like you game people, most of you, I don't think, almost no one in the game group said that they want to do a multiplayer real-time game. But if you're doing multiplayer real-time and you're sending traffic, a lot of traffic over the net constantly, then your usage might go up. You might have to worry about that. Okay, so once you've chosen what you want, you click Review and Launch, and up comes your instance. And the next thing you have to worry about is what are called security groups. So you can think of security groups sort of as a firewall for your machine. So when you create a machine on the Amazon cloud, you have to decide who has access to that machine and what access they have to it. So for example, does anyone remember what port HTTP runs on? 25? It's 25 is Mel. 80 is the port. So port 80, for example, needs to be opened up because if you don't open up port 80, no one can talk to your machine using a web server or web browser, which is an important thing because we're making our web servers on the machine. On the other hand, the mail server is 25. Should we open up port 25 on our machine? If your machine is going to handle requests for mail, then it does need to open up port 25. On the other hand, if you open it up but you're not doing anything with mail, you've just created another vector where someone can attack your machine. And you probably don't want to do that. So we'll see that in a second as well. Another thing that we're going to do is we'll create remote desktop. So remote desktop allows you to remote desktop into the machine. So if you want to modify it or do something with it, you can use RDP on the Windows box. Yeah?
So you mentioned port 80 for like web, for some web clients who wants to make a key, but does that apply to apps as well?
Apps usually are using the HTTP protocol, so they use port 80 as well. That being said, HTTPS is on a different port. Anybody know what that port is? 443 is correct. So you need 80 for your non-secure traffic and 443 for your secure traffic. And those are the two main ports. In 3500, most of you wrote a multiplayer game of some sort. You had to open up a port, and I believe Danny said choose port 5000 or 10,000 or something. If you were doing that on Amazon, you would have to open that port through the security to let people access it. Okay. All right. Once you've done all this, you'll pop up a screen that says, I need a way for you to prove you're you. So right now, when you get your laptop, all of you got your laptop, it comes in the mail, and you open it up, and it says, welcome. How does the laptop know you are you? How does the laptop know you are you? I mean, when you open your laptop for the first time, it didn't say, hey, Jim, glad to see you. Right? No, it didn't do that at all.
Oh, usually you got a Windows laptop, you got the Microsoft services that run behind it, and also you have the product key.
You have the product key if you're installing stuff. But when it first pops up and it opens, what does it say? It's been too long. Shut all your laptops. It says, who are you? And you have to type in your name. You say, I'm Jim. And from then on, it knows you because you're the first one to have access to the machine. So our web server, we need to tell it that we are the first one that's logging on, that we have access to it. And the way that works is we are going to create an encryption file that protects our password. So This stage allows us to create an encryption file. This I called mine CS-4540 test 1, and that file is going to be on my laptop. So when I want to communicate with my web server in the cloud, I use that file to prove who I am. And I'll show you how that's done in a second. So we choose our file, we click our launch, and boom, our machine will start launching. Now, how many of you have a really old laptop in here? No one has a really old, how long does it take when you shut it down all the way and bring it back up?
5 minutes.
5 minutes. Great. Exactly. So here, we are really waiting for like 5 minutes for our really small web server to boot itself up and get started. Once it's started, it'll be okay, but it's going to take several minutes for this thing to come on because it's a tiny little web server somewhere, and it has to be completely built from scratch the first time, and it's only got 1 gig of memory, and it's got a small CPU. Okay. Eventually, we will come back to our instances, and we will see that we now have 1 running instance. We click on that, and it will take us to this web page where it will show us all of our machines. So here you notice that I have 2 machines that I built before that are stopped, and I have a third one that is currently running. And that running one has a public DNS. So this is really important. This is the name of the machine. So if your friend knows this name, they know this name, and they know what time you're doing your display to the TAs for your final grade, and they write a denial of service attack on that machine, then your grade can go down. So those of you who want an extra project to help, like if we're on a curve, to like boost your position on the curve, if you find out that name, you could use that to attack their machine. Now, hopefully Amazon would protect you, but all right. Once we've got a machine running, if we want a remote desktop to it, we click the connect button. So it's up here. We'll come here where it says, all right, you want to connect, you need a password. So here's where the machine is. Here's the username. So by default, all of us will use administrator for our admin name. And then we need to get a password to allow us to get in there. How are we going to get that password? Remember that file that we created a second ago? That file is going to let us get the password. All right. So let us actually do this. Let's go away from PowerPoint and go into the world. So Amazon Educate. Let's see if this will bring me the right spot. So I'm going to AWS Educate. So here's that page where, like I said, I really want to click this, but that's not it. I have to come down to the sign in to AWS Educate. Hi, welcome back to Educate. Down below is my content, my credits, my classroom. But really, we don't need any of that. What we need is our AWS account. And so we click on our account, and it comes over this giant AWS Educator Starter Account button. It's not even clear that's a button, but I guess it is. And we click on it, and it brings us to Vocera. And Vocera says, here's all your stuff. And you notice over here on the left side is a whole bunch of facts and information that you can read over. And then over on the right side is my actual account. So because I'm a professor, somehow they give me $150 instead of $50. So that's sort of nice of them. Session times, how long you've been logged in, and whether you're active is up there as well. Yeah?
Sorry if you mentioned this. Does every person in the group need to make one of these?
Does everybody in the group need to make one is the question. And the answer is yes. Every one of you in this class should build an instance at some point and deploy your project to it. But that's for your own edification, really. At the end of the day, we will ask, where should we go to look at it? And you'll have it running on one instance. Yeah. Okay, so from here, what do I click? Does anyone remember? Well, my options are classes, note, manage, note, domain, note. So over here, either account details or AWS console. What do you think? Account details it is. Oh, that's some weird stuff. Wow, look, it's credentials. That's exciting. I don't even know what's there. Okay, AWS console, that is the correct answer. And so we come up here where it will tell us my home region is North Virginia, and there's my domain, so everything looks good. I want to go to my EC2, so I'll click on EC2 and come to my dashboard. And on my dashboard, you can see I have one running instance, but I want to create another one, so I'm going to do launch instance. And here are all the different types of machines that I can choose from. Ubuntu servers, Amazon Linux, NetCore 2.1, deep learning-based Amazon Linux machine. There's all sorts of different environments that are already pre-built.
So one quick side issue here. Once you build your instance for the first time, you're allowed to save a copy of it. So all this stuff that we're going to go through about building our image and putting software on it, you do that once. And actually, as a software developer, you probably will never do that. Someone in your IT staff or your company will give you the image, and then you'll just spin up the image. But I want us all to walk through this process once to see what it takes to actually build an image from the beginning. Okay. So we have all these nice feature Linux machines, but I'm going to find the 2019 Windows Server base, and I'm going to select that on 64-bit architecture. And it does say feature eligible, which is nice. 6 months ago when I was playing with this, Windows was not free at all. There was no free versions of Windows because of the licensing agreement. I think Microsoft got smart and figured we should let people play with Windows so that they'll buy it when they become grown-ups. Okay, so I'm going to select that one, and now I get to choose. So as I was saying, there are lots of different options. T2 micro is one we'll play with. You can also play with small, but there's large, there's extra large with 32 gigs of RAM, which would be nice. There's these M5DMs, there's R5DMs, there's C5Ns, there's P2s, P3s, R5s. I don't have a clue what happened. I don't have a clue what 90% of these things are, but they're all just various versions of machines. So for example, if you wanted 2 extremely large SSDs, so you wanted really fast disk access, you might choose to use this thing. Now, my guess is that this is one of the machines that's going to cost, $1 an hour to run. Now, is $1 an hour a lot?
For me, it is.
For us, absolutely. Yeah. But for a company, how much is it going to cost me to buy a really high-end machine and pay someone to maintain it and get internet connection to it? $1 an hour might be really cheap. Okay, but anyway, I'm going to go back up all the way here to my general purpose T2 micro, and I'm going to review and launch it. So I'm going to go and launch my instance. So before I launch it, it says, hey, in order to launch, eventually you're going to need a password. In order to get a password, you need one of these data files that proves who you are. And so most of you will have to choose create a new key pair. But since I've already created it, which is, by the way, the key pair is just a file that's on my desktop, I'm going to just use that and launch my instance. So your instances are now launching. You can view the launch log. It was successful so far. Create billing alerts, get notified of estimated charges. So this is for me. Let's click on create billing alerts. You don't have permission to do this because you're an Educate member. So why did we give you that option in the first place? Because we're bad at this. I don't know why. But anyway, yeah, I thought, oh great, I don't know how much it's going to cost me or my students. Let's create billing alerts so when we spend $10, everyone would know that they're a fifth of the way through their money. And I went here and it said, sorry, you can't do this. So we just have to watch it ourselves. So let's go back to our services. So under services, I'm going to go to my EC2 instances.
And we can see that I now have 2 running instances. And the one that I just built is this one right here, the third one. It's running, but it's initializing itself. So the first time, again, you start up, it's got to make sure that it installs the operating system. It gets everything ready to go. As it's initializing itself, if I click on it, down below, we will see there's a whole bunch of interesting information. The description is what you're going to use most of the time because it tells you things like the public name of the device. But there's this nice monitoring tab. If you click on it, it will show you how much the CPU is being used. So if you suspect that one of your friends is doing a denial of service attack, you can come here to this monitoring and see that it's spiked up and know that something's wrong. Okay, but our purposes, we're just going to see, okay, there it is. There's our machine that we want to go to. And so I'm going to click Connect. All right, here's where it's asking you for the password, and the way you get the password is following. You click Get Password. Oh, sorry. You click Get Password, and it's going to say, where's that file I gave you? And I'm going to then choose my file that I saved on my desktop, my secret file, and decrypt the password. And there is the password to my machine. So now I am going to remote to it. Yeah, so remote desktop. I choose the name of the machine that I'm remoting into. So let's grab this machine's public DNS. Remote desktop. I'm going to choose that DNS and click Connect. It's going to try to connect to it, and it made progress, so it's going to username, and so I'm going to grab the username, and then I'm going to grab the password. And it's going to come up and say, hey, I cannot prove that this is a real machine, because we have not paid for a security certificate that says that we really own this machine as part of our business and stuff. So we will click, don't ask me again, and yes, we are perfectly happy going to this random machine in the cloud. The only reason we're happy is because we just created this random machine. We know it's valid. And you will see now that it's going to take a second to start up. But I have a Windows machine somewhere in North Virginia that I can do whatever you do on a Windows machine is. It gives me all the power of a Windows server. Right, there it is, running in the cloud. You notice that we still have, 6 hours of lecture left? Do you see the time down there at the bottom? No, I don't trust other networks. Yeah, so it's 12:30 wherever this machine is. But that doesn't make any sense. Oh, and 12:30 a.m. Sorry, class is over. Phew, that's great. Yeah, so this one is running on Virginia time, which, by the way, I don't think this will affect anyone in this class, but when you run machines that have a different time from the development time, you will sometimes get into trouble because you will expect the time to be your time and it's really their time. Okay, so this is just a Windows box. It's a plain vanilla Windows box. It doesn't have anything on it. If I try to bring up a web browser will pop up. And if I don't like Internet Explorer, I could simply download Chrome and use Chrome on this machine. But I can go to http://localhost. And if a web server was running, I would get access to whatever's on that web server. Yeah, what's up?
So we have a gig of memory, but how much storage do we have on these?
I glossed over it, but when you're doing that setup, in one of the columns it said how much you had. And I think it's, I forget, it could be 100 megabytes, it could be No, sorry, that's
Wasn't that 1 gig?
1 gig. No, we had 1 gig of RAM, but I think it has access to, I don't know, but it's a reasonable amount of disk space. I suppose we could just go here and say, click on our folder and go to this PC, and we have 30 gigs of space. All right, so you'll notice that the web server didn't start up because there is no web server. Let's do the following. All of you use virtual desktops on your laptops? Okay, that's not what I wanted. I wanted this. Okay, so can't reach the page. Where did I put my PowerPoint? Oh, there it is. Okay. Okay, so here I am back on my virtual machine in Virginia. I'm going to run PowerShell. So PowerShell is a command terminal that allows you access to Windows. Just like on Macs, you can bring up a shell. And inside of this, I'm going to install a web server. And so while that's going, I'll show you the command. The command to install the window to web server is this: install Windows feature -name web server -include management tools. In the PowerShell, you just type that in, and on your machine, a web server starts to be installed. So it's pretty clever. It's going out to Microsoft saying, hey, I need the IIS server code, and it's downloading, and it's getting ready to run that. So as soon as this thing completes, we will have a running web server on our machine. What else do we need to put on our machine?
The files that the website is.
Yes, you're going to have to put your website code on this machine. Turns out that that is going to be a joy once we get everything set up. Why is it a joy? Because in Visual Studio, you will click on the build, you'll go to publish, and then you'll say publish, and you'll give it the address of this machine, and you'll click go, and it will take all of your stuff on Visual Studio and transfer it all onto your machine on the cloud, and it's one button click to put your files onto the machine. We have to do some more setup before that happens.
So what's the difference between doing this and let's say you fire up Visual Studio on this machine and you fire up like an IIS web server like we like to do on our local computer?
Right. So 2 questions. You need an IIS web server regardless of whether you're doing it local or not, and so you have to install it. But the question is, why can't we put Visual Studio on this machine and just do our coding right here? And the answer is twofold. One is you're running with 1 gigabyte of memory on this tiny little machine. A lot of you have already complained that Visual Studio barely runs on your laptops with their 32 gigs or something. So it would be, you need a bigger machine to run Visual Studio. But the other thing is, most cases, developers develop on their laptops. You have a local development environment where you do all the testing, etc. And once you're good and you believe that the website is ready to go, then you deploy it to the cloud. So that's just the way things are done. Okay, have I installed? Oh, great. So if that did its job, which I have no reason to doubt, I can go now to my local host, and Windows has a web server running. What's more exciting is the following. So again, here is my public DNS. I'm going to grab that information. Oh, there's the copy button. I'm going to go HTTP on my laptop, and I'm going to go to that web server and watch as now my laptop is actually talking to that web server. And that web server happens to be Google. Now you see it's still loading. Because it takes an enormous amount of time to get packets from North Virginia to Utah. It's just so far. No, that's not true either.
It's because of
It can't be reached. So I alluded to this earlier. Does anyone remember what I said earlier? Yeah. I have to open up the port. By default, Amazon walls your machine off almost completely. It doesn't want anyone in the world to have access to your machine. The only thing it opens up is that remote desktop. We need to open it up for the web server. So the way we do that we come to our machine and we go to our security groups. So security group 5 is what we're using. And we come to our security group, and the important things are the inbound and outbound rules. If you've never played with a firewall on your own laptop, it has the exact same sort of things. What you allow into your laptop, what you allow out. So inbound rules, you can see that we allow remote desktop. But we're going to edit this, and we're going to add a rule. And here's a whole bunch of different rules that are in place for us. So you see a rule that we might want to use. HTTP. That's right. So we're going to do that. Now, it's going to open the TCP protocol, which is what HTTP runs on, or 80, which we already knew. And then it's going to say, where do you want people to be able to access this website from? And if you were actually running a company, you could decide, should people, for example, in Russia have access to our website? I don't know. Should everybody? So right now, everybody is. But when you're first developing, or even better, when you're displaying your work to the TA and you're worried about your friend's denial of service attack, where would you really want the only people to access the machine? If you're really paranoid, who's the only person you can trust in this world?
Yourself.
Yourself, that's right. And so we're going to come over here to this custom thing. Instead of having anywhere, which is what's the default, we're going to change it to my IP. And so now the only machine that can access the website is my machine. It took a second or two. And now, because Chrome kept looking, and looking, as soon as Amazon realized it's okay to allow access, Chrome got access to my website.
Could you also, like, if you knew, like, what, I guess, like, subnet the University of Utah servers had, and like, assigned out, you could restrict access to only University of Utah computers or computers connected to only University of Utah Wi-Fi?
So the point that has just been made is here where you say who can access it, you have my IP address, you have anywhere. It turns out that you can, those are not your only options. You can edit this really archaic syntax to say only allow certain nets in the world access. And the University of Utah network has, like 155 dot this, dot that. You could put that in there, absolutely. So anyone at the U could access the website, but no one outside of the U. Okay, so we have now built a virtual machine, made it run in North Virginia, created a web server on it, started a web server, and shown that we can connect to it from our laptop. Let's see, though, let me come here and change this rule, edit the rule, custom, anywhere, save. Okay, and those of you who have good vision, type this, can you read that? Type that into your laptops and see if you can access my website. EC2-18-207-201.amazon-aws.com. Let me know if you get this. Did you get on it? Yeah. So we are now, I could be feeding a Google ad. I could be playing a video representing, buy Zumba or something. I could be making money right now off of all of my students going to my website. Okay, so what's the next step? Next step is we install the Visual Studio libraries to make Visual Studio Code run, the SP Core libraries on a machine. We install the one-touch deploy code. And then we go to Visual Studio and we send our code to AWS. Those are the next steps, and then we're running in the cloud. There's one more step. What's the other big component? We have a web server, we have our browser front end, we have web server back end. What's the other big step we need in order for web software to work? We need a database. Right. So you have two options for databases, and we'll get to this next week. One option is we have a Windows machine running. Can we put a database on a Windows machine? Sure, we can run the database directly on our web server machine. And I think that's sort of old school. That's the way things were traditionally done. You could serve both the web server and the database off the same machine. Amazon, though, has, under its compute options, so under the different templates, I think, but if we just go to our EC2, no, those are my templates. So if we just go here to services, you'll see that they have many, many different types of services, but one of these is databases, and yeah, there it is. So instead of running a database on your own web server, you can just spin up a database directly that's on another machine, and then have your web server talk to that machine. And that's what we'll probably be doing next week. So again, you should not be worrying too much about getting your stuff onto AWS at this point. You should play with getting an instance up and running so that you run through all the steps. And be aware that at the end of the semester, we do want to deploy out to the cloud so you can see how that is done and how easy it is to do. Unusually, I have run out of stuff to say before I ran out of time. So, if you have questions about your project or your team or the course, feel free to come down and talk to me. Otherwise, you have an extra 10 minutes on your time.